In this tutorial, we will talk about projections and how to transform from one projection to another using projection transformation. If you haven't done so, make sure you have an empty map document. So if you haven't done so, click New Map File and select Blank Map so that you don't have anything on your map. Now if you right-click Layers and check the properties of this layers, you will see that there is no projection set up for this layer. Turns out it's the first layer, first feature class or first raster image that you would open in this layer will set the projection of this layer. For example, if you load the image, QuickBird image from your lab 1, and now look at the projection of this layer, you will see that it has been set to NAD 1983 UTM Zone 11N. And any subsequent layers that you add into this table of contents will be on the go projected to NAD 1983 UTM Zone 11N. So in order to test that what happens if we bring a layer of a different projection, bring the UNLV intersections into this layer or data frame, and you will see that it is giving you that warning that the file that you're trying to bring in is in a different projection. Once you close, it will automatically project it for you in this NAD 1983 datum and UTM Zone 11N projection. And you can tell that the points are showing at the correct places. Now in order to test this thing, we will add another frame and try to see what happens if we bring the layers in a different order. So let's add a new data frame, and if you look at the properties of this data frame, you will see again there is no projection. Now drag the UNLV intersection, and in case you cannot drag it, you will see that maybe you are in List by Source tab. In that case, go to List by Drawing Order tab, and now you can click this UNLV intersections and drag it into this new layer. Now if you look at the properties, you will see that the properties of the new data frame are WGS 1984. In case you try to drag the world imagery here, you will see the same warning, which is that the world imagery is in NAD 1983 that is being transferred into UNLV intersections. So either way, the purpose of this is to show you that even though the original file projection, the way it is saved on the disk, does not change, when you load a given file into ArcMap, it can change the projection on the run to match different projections and show you the location of things at the right places. So even though ArcMap can do the projection transformation on the go, if this is a very big file with many points or raster data which is very large, this on the go processing can slow down the way ArcMap responds to you because it is doing this extra work. So sometimes it's beneficial to reproject the layer. For example, as we saw that the QuickBird imagery is in NAD 83, whereas the UNLV intersection is in WGS 84. So what we will do is we will reproject the UNLV intersections to NAD 83. For this, you need to learn about the Arc toolbox. So if you click Arc toolbox from the toolbar, you will see that a list of tools will appear next to the table of contents. Now this is the toolbox that provides many programs and algorithms that can be used to do all sorts of processing for image, raster data or vector data, and it has these main groups of different groups. For example, 3D Analyst and all the tools that are provided by 3D Analyst. In this case, look for data management tools, and in data management tools you will see a group called projections and transformations, and this is where we will find the program to reproject UNLV underscore intersections shapefile. So in projections and transformations, you see two sub menus: this feature and raster. So if you were trying a raster image, then you will use the options under raster. In this case, because we have a point data, we will use feature, and there's a tool called project. That's what we're going to use. If you double click the project option or project tool, you will get this menu where you have the information about the input data and the output data and the transformation, and the blue dots provide the required information. So if you pull down the input data set, the file that you have open is already listed there. In case it wasn't, you can always select the browse button and find that, and it already is telling that this is in GCS WGS 1984 format. Now to provide the output, it's putting it at a default place, but we want to put it in the lab 3. So you can always select the previous name and call it with a new name, for example NAD 1983. It may not like such a long name, so you may have to reduce the name to UNLV inter NAD 1983 shapefile, and you can click save. Now the other thing that you need to provide is what do you want the output coordinates to be. So if you click this, the same kind of menu appears that you have used before. You can go to select geographic coordinates, North America, and NAD 1983, and this will add that to the list. Now you need to provide a transformation, and this is basically telling it how this needs to be transformed. So there are several transformations available. What we need to do is get WGS 1984 to NAD 1983, and once you select this, it will appear in this lower window. So all the information has been given. Once you click OK, it will start to process it, and you will see the processing of this happening at the bottom. It will appear every once in a while and then go away. Once this is complete, the new feature class will automatically appear in your data frame. So if everything went well, you should see a new layer appear in the data frame, and if you look at its properties, you will see that its datum has changed to North American datum 1983. Now let's do the experiment. Let's open another empty data frame and transfer the QuickBird imagery into it, and transfer the new shape feature shapefile into it. And if you see that no warning was generated because both of these layers are in NAD 83 datum, and of course the image is using UTM zone 11N. So what you learned today from this exercise is that it matters if how the two projections are. If they have the same datum and the same projection, then you will not get that warning, and the program will not have to go and change those change the coordinates on the go to make sure that you have the right image. And this is how you can convert the projection of a feature class in this case, and also you can do the same process for raster images as well. So this concludes our tutorial on how to project a feature class from one projection or one datum to